Hi everyone. Today we're going to be talking about the three different ways that solutes go into solution. And you might be asking yourself, oh, why do I care about that? Well, picture this. I know that a lot of you may be athletes, and imagine this. Imagine that you just finished the Boston Marathon and you get done and your body just collapses like you're not able to even move anymore. Why might that be happening? Well, it's due to the way that solutes go into solutions. Another example, we put different kinds of salt on our roads at different at different temperatures. Why might that matter? Oftentimes, the pipes that we have running in our house get filled up with crud. Why does that happen? And all of these things can be explained if we understand, again, how those solutes actually go into solution. So just as people react differently to the same situation, here this guy's winning $1 million, and two different people one might think, oh my God, all the taxes that I'm going to have to pay, and then another person might be thinking, oh, think of the island I'm going to buy. Well, chemicals are the same way. They react differently in the same situation. So the first type of situation or equation we're going to look at is called a hydration equation. And in this case, no ions are formed. The molecule actually dissolves as a whole. So basically what this means is that if, for example, we have sugar here, and when we add that to water, so it's over the arrow, so that means it's not part of the a reaction, we're just adding water to that. What happens is that water doesn't split up, it stays whole. And so these are actually the easiest to basically write because we have a covalent compound on the left side, and then all we have to really do is just rewrite it on the right side. So a couple of key ideas with this is that typically they don't have a metal in them. There are no ions present. All right, that's a key one. And the same number of particles are formed as was originally present. So basically, again, that's saying that all we have to do is really rewrite this. And you'll notice that for every 1 mole that goes into this, we're going to get 1 mole out. That's kind of important when we go to kind of explain, well, why some of those slides in the beginning, when we talked about why this matters, this is our key to kind of explaining this. For every 1 mole that goes in, we're going to get 1 mole out. So you'll notice that on each of these slides, I have the assignment posted down here in the bottom as far as how these correspond. So for example, in our first example for section A, we can tell that this is going to dissolve as a whole molecule because it's a sugar. All right, so we're looking for sugars or anything that ends with that OH, so alcohols or sugars, in this case, carbon, hydrogen, and oxygen combination. So go ahead and fill that in. Next, we have a dissociation equation. So these are actually going to break apart. They're going to separate. Our classic example of this is salt, something that's ionically bonded. So we're going to write the ionic compound on the left side. We're going to then split that apart. All right, so we're going to separate it into its individual ions. And then we got to, of course, make sure we balance it and include subscripts and superscripts. So a couple of key ideas with this, we're going to see a metal and a nonmetal. So unlike letter A in that previous, where they dissolve as a whole, we're looking for sugars or alcohols. In this one, we're looking for some sort of an ionic compound, a metal and a nonmetal. And you'll notice that in this example, we've got aluminum nitrate. What happens is we start with 1 mole of the aluminum nitrate. When we balance the equation, we see that we actually get 4 moles out of it. So we're getting more particles than what we started because, again, it's breaking into smaller pieces. And this is very similar to what you'll see in the B section under dissociation. So give those a try. Lastly, we have ionization equations. And these typically deal with acids. So again, the way we identify an acid starts with an H usually, typically. And so when we see that an acid is reacting with the water, what's occurring is we're basically turning this water, for example, into an ion. So it's changing from, this is really just a covalent polar molecule, and it actually turns into an ion. And what we're going to do, again, write the covalent compound on the left side and water, and it's going to split apart and form the hydronium ion. So that hydrogen from the HCl, you can almost picture it popping off here and going on to the water, and we call that the hydronium ion. And then we also get what's left over, which would be the Cl. And then, of course, we would go through, we'd balance the equation and include any sub or superscripts. So again, acids typically start with an H, and we're going to get ions forming as a result. And again, this is another example where we end up with more particles formed than there were originally, because that HCl is really splitting apart. So we might write it like this, where we're adding the water to the HCl, and we get that hydronium ion and Cl. However, a lot of times, again, lazy chemists, we don't write water, we just kind of take the water out of the equation. When we do that, when we almost subtract the water from the left side from the right side, we're left over with HCl, giving us this H plus and Cl minus. And these are going to be corresponding to what you see in letter C. So again, try those out. So here's kind of a summary that I would suggest adding to your notes. We talked about ionic substances dissociating. We got a couple of examples and how we would do that. We talked about hydration and how alcohols, sugars, and also weak acids, which we'll talk about later, dissolve as whole molecules. And then over here, we have strong acids. So strong acids like HCl are going to ionize, and they're going to give us that, again, hydronium ion. So hopefully this video was helpful. Please go through, please try out. You should, after this video, be able to do letters A, B, C on the front page, and then also you should be able to do 1 through 12 on the back side. In another video, we're going to talk a little bit about the bottom half of these, which involves writing ionic equations. Please talk to your teacher if you have any further questions.